Hi boys and girls, this is lesson 5.7, all about subtracting fractions. Please get that written in your notebook as well as today's date, and then come on back. So the first thing I want you to do is solve the following problem. Just give this a try in your notebook. It says this: Ella bought 7/8 of a yard of fabric to make a pillowcase. She used only 5/8 of a yard. How much fabric does she have left? Okay, see if you can figure out how to solve that problem, and when you think you have it, come back and check out the next slide. Okay, so 2/8 of a yard is the answer. Hopefully that's what you have. Here's some of the ways you could have come up with it. You could have used fraction names. Again, we're back to counting these as the unit. 7/8 minus 5/8, or I could replace this with hats, right? Is the unit is eighths, so it's equal to 2/8. I could definitely do it that way. I could use the relationship between addition and subtraction. 7/8 could be decomposed into the sum of 5/8 and 2/8. So therefore, if I know that to be true, then 7/8 minus 5/8, 7 minus 5, equals 2/8. I could do that. I can draw something. So the red circle is the whole. Show 7/8 with 7 dark blue pieces to represent how much fabric she started with. Take away 5/8 or 5 of the dark blue pieces to represent the fabric she used. And the pieces that remain represent how much is left. And you can see that there are 2 left. And that's how we could do that. So we've got these 2 left, right? So that's another way. We could do it this way as well. Red circle is the whole, 5/8 is here, then add dark blue pieces one at a time to get the total amount that she started with, and the 2 dark blue pieces that are added represent how much fabric is left. That works. I could use the number line poster again. So 7/8, and I'm going backwards now, so I'm counting back 5/8. 1/8, 2/8, 3/8, 4/8, 5/8, because that's the amount she used. I'm going to end up at 2/8, and that's the amount that is left. Okay? So I could do it that way. Those are all different options for you. So see what you like. And you may have even had another strategy, that's for sure. Okay, so we're going to be solving number stories today that involve subtracting fractions, and they are going to be referring to the same whole, and they are going to have like denominators today. So keep that in the back of your mind. So here's a question for you. Dakota lives 7/10 of a mile away from the community pool. Tyler lives 3/10 of a mile away. How much farther from the pool does Dakota live than Tyler? Think about the words that I'm using in that sentence that should be giving you a hint as to what kind of a problem it is. I'm telling you this one is this much and this one is this much. How much farther is what I'm asking. So hopefully you can figure out what kind of comparison problem that is. Some questions I would be considering. What's the whole in this? Does each fraction in this problem refer to the same whole? And will the answer be more or less than a mile? So think those things through and think the problem through. Do some work in your notebook, and when you think you're ready to take a look at what I said, come on back. So here's the first couple things. One, the whole is 1 mile, right? Because it's 7/10 of a mile, and it's 3/10 of a mile. So the whole is the 1 mile. And each fraction does, yes, refer to the same whole, both times a mile. And the answer is going to be less than a mile because each of them were less than a mile, and I'm comparing them. So hopefully you have that. And then here's some strategies I might have used to solve it. I could have used the fraction names again and said 7/10 minus 3/10. Again, using the tenths as the unit equals 4/10. 4 hats, like we talked about in class. Or I could be using the number line again. So I'm at 3/10, because that's how far Dylan was, I think. So 3/10, 1, 2, 3, 4/10 is how many tenths it would get until I get to Dakota's 7/10. So the difference between the two are these 4 tenths. And that's how I could do that problem, either way getting 4 tenths. Those are a couple strategies. Again, you might have yet another strategy. As long as your strategy is getting you to 4 tenths, that's great, and maybe you can share one of your ways with me in class. Here's another problem for you. So Kyle's goal is to finish 1 science fiction book by Friday. Great goal to me, sounds like. On Wednesday, he had finished 4/12 of the book. How much does he still need to read to reach his goal? Again, the questions we should think about. What is the whole? Does each number refer to the same whole? And do you think the answer will be closer to 0 or to 1? So think that through, jot yourself some notes, come back and take a look. And also see if you can solve the problem while you're off taking a look before you come back, right? See if you can solve the problem and figure out a strategy to use. Okay, so some things that we would fill in. The whole is 1 book, the whole book, right? The answer is referring to the same whole. I mean, but each of the numbers are, the 4/12 and the 1 science book are referring to the same 1 science fiction book. And it's going to be closer to 1, the difference. And I know that because 4/12 is less than half, and I'm needing to get up to the whole, so it's going to be closer to 1. To solve it, here's a couple things I might have done. I might have renamed the whole number as a fraction with a denominator of 12, because I know 12/12 is the same as 1. Then I could use fraction names. 12/12 minus 4/12 equals 8/12. The unit, again, in that one is 12ths. So I could do it that way. Or I could draw a picture to represent the book, shade the part showing how much Kyle has read so far, and what's left unshaded is how much he needs more to reach his goal. So in my very lovely drawing there, you can see I tried to, in yellow, shade in 1, 2, 3, 4 parts. 1, 2, whoa, sorry guys. 1, 2, 3, 4 parts there, and then I've got 1, 2, 3, 4, 5, 6, 7, 8/12, 8 parts, 8/12 left to go. So I could use either of those strategies or methods to solve that, and you again might have yet another one. Hopefully you're getting the answer of 8/12 as your answer. Okay, again another one now. The girls and boys soccer teams each have 18 players. 1/6 more, that's a really key word there, more of the girls' team attended summer camp than the boys' team. 5/6 of the girls' team attended camp. So what fraction of the boys' team attended camp? Questions to think about. What's the whole? And did more, less, or exactly half of the girls' team attend camp? That's going to give me some number sense as to what I'm looking for here, right? So think those two things through, see if you can come up with a way of solving that problem, and then come back and check your work. So we can see that the whole is the 18-player team, or the team of 18 players. Either way is definitely right. And we should be able to see that it's going to be, or that it was more than half that attended, because 5/6 of the girls' team attended, and half of 6 is 3. So 5/6 is definitely more than half, getting pretty close to the whole, right? All right, again, think about that problem. If you did do that before you came to this slide, that's great. You can just go on to the next one. If you haven't yet tried to solve the problem, go ahead and do that and then come back. Here you go. A couple things you might have done. You might have used the relationship between addition and subtraction, thinking of the problem as b, or some variable letter, right, plus 1/6 equals 5/6. We don't know what that amount is yet, but I can think about that and say, well, I know 4/6 added to 1/6 is going to equal 5/6, so the amount that I'm looking for is the 4/6, right? I could think of 1/6 of 18 as 3, right? So if that's true, then 5/6 of 18 would be 15. 15 girls attended camp, and 15 minus the 1/6 more for the girls, so minus 3 boys, would give me 12 out of 18 boys that attended camp. and that's 12/18. Or if I look at that, I can change 12/18 down to 4/6 of the boys' team, because remember, I can do, if I'm trying to do common denominators, I could do what number can I divide 12 and 18 both by to make it lower? Well, I could divide them both by 3, and that's going to give me, I know 3 times 4 is 12, and 3 times 6 is 18, so I know I can do that, right? It's the opposite of how we were making equivalent fractions with multiplying. I just did the opposite there. So I can know 4/6. Either of those two ways is my answer. That's what I'm looking for. All right, so those problems were all a little bit different from each other on purpose. You're going to have some of those kinds of problems now on page 169 in your math journal. Give those a try, and I will show you the answers on the next page, so don't flip to that until you are ready to see what those answers are. And correct it in pen so that we can look at it together, problems that gave you some difficulty in class. All right, I hope you have a great night. And there are those answers.